Okay, hi everyone. I'm back with another video review, and as the title says, this is going to be my review of the Ultimate Ears Reference Remastered custom in-ear monitor. So I firstly want to thank Kelly Bishop at Ultimate Ears just right off the bat for the very generous offer on the Reference Remastered, and I want to thank all of the people at Ultimate Ears for making this product even possible. So without further ado, let's get on with the video. This is going to be a long video, just to let you guys know. So if you check the video description below, you can see the links to where all the different segments are in this video. So first of all, I want to cover the kind of background of the in-ear monitor and what exactly it is. And so I will start off with the history of the in-ear monitor. So back in the early 80s, before the in-ear monitor was invented, and is still kind of popular today in small venues, live artists would come on stage, and on the stage in the front of where the artist would be performing, there would be some speakers that were pointed at the artist. And so the purpose of those speakers were so that they can monitor sound cues and whatnot, so that they know when to play certain notes and instruments in the song that they are performing live. And one of the problems with those stage monitors is that, one, you get a lot of noise from the live audience shouting at you and cheering, and two, you get kind of not so great audio coming out of these stage monitors. And so with the introduction of the in-ear monitor, it made that process a lot more high fidelity. And so the live performers were allowed to have a lot more noise isolation because of these custom in-ear monitors, or in-ear monitors in general. And they were able to hear a higher fidelity music stream being played into their ears, so that they can know when to play the bass guitar, the drums, singing, etc. on the stage. And so that's kind of how the in-ear monitor was originally used for. Now, if you fast forward to today, a lot of people call in-ear monitor, or a lot of people call in-ear earphones in general iEMs, and that's kind of where the term came from, is that they came from these in-ear monitors that professional audio people would use. And so today I have the Ultimate Ears Reference Remastered custom in-ear monitor. And so inside of the box, or not really the box, inside of this hard case, this is a titanium case, hard shell, and soft foam inside. Inside you would usually get the UE buffer jack, which is basically the same thing as the iFi iEMatch. I just put the iEMatch in here because it's a little more convenient, and it has the ultra setting that I really like to use. You also get this 1/4 inch adapter, as well as this cleaning tool. So this cleaning tool has a metal pick on one side and hard bristle brush on the other. So those will be used to clean your in-ear monitors. And so now that we have talked a little bit about the history of the in-ear monitor and what it's used for, let's talk about Ultimate Ears in general. So Ultimate Ears has been involved in this in-ear monitoring business for quite some time, since 1995, when it was founded by Jerry Harvey, which many of you have also heard because of JH Audio. So Jerry Harvey kind of started Ultimate Ears, and they collaborated with Westone actually to start making their in-ear monitors. And then they branched away from Westone and became their own individual company. And then Jerry Harvey actually left Ultimate Ears to create JH Audio. And then Ultimate Ears was acquired by Logitech, which many of you know from their large amount of PC peripherals, so mouse, keyboards, etc. So Logitech acquired Ultimate Ears in 2008. My history with Ultimate Ears actually stems all the way back from around 2004. So when I was in middle school or high school, I had seen a live performance of Seal, the artist who sings Kiss from the Rose and Crazy. I had saw him on TV performing live, and he had these pink earpieces in his ears, and I was just wondering, well, what the heck are these earpieces? What are they used for? Why are they pink? And so I looked on the internet back in the day, and I had come across Ultimate Ears, Westone, Etymotic Research, and Shure for these in-ear monitors. And so many of you know these companies because you guys are involved in this audiophile scene and you know these companies very well. So Shure makes in-ear monitors, but not custom in-ear monitors. Westone also makes in-ear monitors and custom in-ear monitors. Etymotic Research is known for their ER4 series, which is a reference kind of engineering sound monitor, and Ultimate Ears, which creates many different products from drummers to singers. And so in 2010, Ultimate Ears had collaborated with Capitol Studios, who is one of the biggest record labels out there, so Capitol Records. The sound engineers from Capitol Studios collaborated with Ultimate Ears, and they created the predecessor to this Reference Remastered. It was called the UERM, Ultimate Ears Reference Monitor, and now they had revamped that sound in 2016 to create the Ultimate Ears Reference Remastered, the UERR. And so the UERR is kind of an improvement of the UERM in the sense that Capitol Records and Capitol Studios Studios A and B had revamped their monitoring system, so their actual speakers, and so they had tuned the Reference Remastered to sound similar to those speakers. And so one of the reasons why I will talk about this a little more, that the UERR has some proprietary and patented technology, is that the studio engineers at Capitol Studios wanted to have a sound that matched the performance of high-resolution music. And so with the availability of high-resolution music nowadays, they wanted to create a monitoring system that can take advantage of the clarity that you would usually get from high resolution music playback system, such as their revamped speakers. And so these in-ear monitors were modeled after those studio speakers. And so now that we have talked about the UE experience, let's talk about how these are actually made. So these are custom in-ear monitors. So these earpieces will not necessarily fit very well inside of your ears. They fit very well in my ears because they are custom in-ear monitors specifically made for the shape of my ear and my ear canal. So as you can see on the screen here, the shape of this in-ear monitor is actually pretty interesting. So this goes on the helix of your ear, this goes inside of your ear canal, and I will show on the screen how you would typically insert these custom in-ear monitors into your ear. So it's not like a traditional foam or silicone ear tip where you just stick them in. You actually have to kind of rotate it in and then kind of wiggle it to make sure that creates a good seal. And this will be important later, but if you don't have a good seal, you won't get very good sound from these custom in-ear monitors. And so if we go back on the screen here, the custom in-ear monitor that you see on the screen has been made from UE's kind of brand new, well, not really brand new, but very streamlined process of getting these out into the market. And so traditionally, when you wanted to get a custom in-ear monitor, you would have to go to an audiologist and they would fill your ears with this silicone material. It's very like foamy kind of feeling, and it would expand in your ear and it will create an impression of your ear canal on the outside ear, so like the helix and the cymba cavum here. And so when they created that impression, they would send it to Ultimate Ears, and Ultimate Ears would kind of refine the shape of that impression, that molding of your inside of the ear, and then they would make a silicone cast out of that. And so with the silicone cast, they would keep that in archive. So in case you needed a new in-ear monitor, they would be able to go back to that cast and make a new monitor for you. And so from that silicone cast, they refill it with silicone material, and then they kind of hand shave it so that it looks smooth and very nice and snug when it gets put into your ear. And so that's a very laborious process, and you actually have to use tools to physically shave the silicone. And so once that's done, they dip that mold into some wax, and then they make a colloid cast from that. And so that's a second cast, basically, the modified cast. And so that cast will be filled with an acrylic material. That acrylic material will coat the inside of the cast and fill it up, and they will put it inside of a UV oven. Basically, using ultraviolet light, they will cure the hard acrylic on the outside, and then they will pour out the excess acrylic back into their collection bottle. And so now that you have this shell that has been cured, they put it back in the oven and it gets UV cured again. So now the inside of the shell is hardened, and then they will pull it back out and they will fill the inside of the shell with your drivers and crossover networks. And then from there, they kind of put all the wiring in, and then they seal it off on the top, and then they make sure that it goes through their quality control process and make sure that it has a good frequency response, and then they finally ship it to you. So it's a long process, but Ultimate Ears has kind of revamped this process in 2009. They started to use 3D scanning technology, and so instead of having the physical impression done in your ear, create the cast of that, create the silicone mold of that, and then create a second cast, they would have a 3D scanner scan the original impression that you got from the audiologist, and they would have that as an archive copy instead of the physical cast. And then they would be able to modify that, I guess, digital impression now inside of software. So now they can do everything digitally. So in a computer-aided program, computer-aided design program, so CAD, they'd be able to modify that. And then from there, they would be able to 3D print a physical shell of that earpiece from the digital file. And so that process has been streamlined fast forward to today, and now UE trains technicians to have a digital scanner so that it allows them to use a digital tool to scan the inside of your ear and create a digital file from there, instead of having the physical silicone original impressions that you would get from the audiologist. And so with that, then they go through the 3D CAD program, modify the shape of the earpiece, and then they 3D print it. And now that they have this empty shell, they would fill it up and then put the cap back on, and then go through their quality control process and then ship it off to you. So that's their new streamlined process, and that's how these earpieces were made. I had gone to a certified Ultimate Ears technician, and they 3D scanned my ear, so now that's in my archive forever, as long as they back everything up. And then they 3D printed this earpiece, shaped it and molded it, put drivers in, quality controlled it, and sent it off to me. So that new process takes about a week, whereas it would take a couple months before. And Ultimate Ears has kind of been the spearhead of this manufacturing process, in that other audiophile companies and in-ear monitor makers are starting to use that 3D printing process as well. So kudos to Ultimate Ears for getting that manufacturing process very streamlined and very quick. Alright, so now that we have talked about how these earpieces are actually made, let's talk about the technology that is put inside of these. And so during the manufacturing process, they put the drivers in the shell and the crossover networks and whatnot. I don't know if you can see it on the screen very well. I'm recording this in 4K so that you guys can maybe see this better. There are 3 drivers on the inside of these earpieces. So there's one there, this kind of large vertical stack, and then there's a smaller vertical stack next to it. Let's see if we can get that in focus. And then on the front side, Let's see if the camera will get the good angle, not on that earpiece. But on the front side, I don't know if you can see it there, but in the very middle, right there, that's another driver. And so what's unique about these drivers is that Ultimate Ears had patented this driver configuration. They call it the true tone drivers, and this is supposedly able to deliver audio at a flat frequency response from 20 hertz to 18 kilohertz. And so I'm not sure what their definition of flat is, but that's what they claim, is that it creates a flat frequency response all the way up to 18 kilohertz, which had previously not been done before. So what's special about this middle driver is that it's actually wired in the opposite direction of most balanced armature drivers. So usually you would have the wiring in the back, like these back drivers here. You would have the wiring in the back, and then you would have the sound tube coming from the front of the driver. So if you're able to see, you can see right over here, that's where the sound output of the balanced armature would come from and go through the sound tube. And so in the case of the Ultimate Ears Reference Remastered and now the UE18 Plus Pro, they use these true tone drivers, so that one in the center is reversed, where the wiring is in the front and the sound tube is also in the front. And they will use these waveguides that you can see on this earpiece. They are 3D printed waveguides here that attach to the nozzles of these balanced armature drivers. And that's called their sound engine technology, and it allows the manufacturing process to be more streamlined. So you take these triple true tone drivers and you put this sound driver, I guess, attachment on it, and that creates the assembly of the drivers itself. So you have the drivers and the sound tubes already attached in one piece. That will go inside of the shell, and then they will do the wiring crossovers above that, as you can see in the helix area there. There's a capacitor and a few resistors in there. So inside of this, there's a three-way crossover. So a crossover is when you have a driver and it's limited in some way, either on the bass, the treble, or bandpass in the center. And then you'll have three driver networks there, so three crossovers there. And then on the earpiece that goes into the ear canal, you can see a red filter there. That's right next to the two true tone drivers, and there's actually 3 bores inside of that. The camera can't really pick it up because it's clear, but there are 3 bores there. So that's basically 3 sound tubes coming up there. Yeah, can't really see it. And these cables are also removable, so it's very convenient to replace the cable, especially for live musicians. That can be important because there are different color cables available too. There's black and this clear one. They call it silver color, but I don't believe it's an actual silver cable. So if you're familiar with audiophiles, they use special cabling sometimes, silver, copper, gold. I believe this is just copper cabling with a silver braid wrap around it. But also Ultimate Ears makes a balanced version as well. So they will have a 2.5 millimeter TRRS balanced cable available for their monitors. So that's kind of neat if you want to listen to your custom in your monitors balanced instead of single-ended. I don't have that cable with me, so I can't tell you how that sounds. So with that actually transitions very well into the sound aspect of this video review. So as I talked about earlier, Capitol Studios and Ultimate Ears collaborated with one another to tune how the Reference Remastered sounds. And because Capitol Studios was tuning it based on how their speaker system sounded in the Capitol Records Studio A or B studios, I guess, they kind of take the sound of a speaker system. And so I will talk about this a little bit more in detail later on, but I believe the Reference Remastered sounds fairly close to a Harman target response in terms of the frequency response. And so let's see. This will be important for later, but on the screen here you can see kind of a rough drawing of different curves. And so these are frequency response curves that are typically seen in audio engineering in general, especially acoustic engineering. Typically what has been done is that you will have two target responses that you can measure microphones in. You can measure microphones in a free field environment or a diffuse field environment. Free field is basically speakers are pointed at you, whereas diffuse field is an average of speakers placed all around you in an anechoic chamber, kind of representing sound coming from any direction around your head. And so if you put a HATS system in the center of a room, HATS is head and torso simulator, so a human mannequin-like microphone, and you play pink noise in this anechoic chamber speaker system, you'll get different responses of the HAT system based on those compensation curves. And so for the free field, you typically see this blue line response, whereas the diffuse field, you typically see this green line response. And Sean Olive at Harman Technologies had created, or he had done a lot of studies based on subjective people's opinions on a preferred headphone response. And that preferred headphone response is kind of similar to how you would hear sound and music in a well put together speaker room. And so because speakers have this phenomenon known as room gain, you would typically get an elevated bass response and a slightly shelved treble response, just because of the physics of sound waves and how they propagate inside of a room. And so this new target headphone response is called the Olive-Welty or the Harman target response. And so the Reference Remastered kind of takes the form of this Harman target response, in that I do find that it has a little bit of an elevated bass compared to what I'm used to with headphones that measure more traditionally to a diffuse field response, such as the HD 800 or the Stax SRS 2170 system. And so there's an elevated bass response and a slightly softer treble response because of that. So moving back to the UERR, as I had just talked about, I find that the bass is a little bit boosted compared to what I'm used to. Another headphone that kind of has this target headphone response is the Oppo PM3 headphone, and I find that the bass of the UERR is a little bit soft, in that it's not quite fast, what I'm used to from open back headphones and whatnot. So it's a little bit of a slow bass response, but it keeps a good amount of texture in there and has very good bass extension, very nice sub-bass emphasis on a lot of tracks that I hear. Very good for listening when there's a lot of background noise and you need to have a little bit more oomph in the low end to compensate for that external noise. And so moving up to the lower mid-range now, so from the bass to the lower mid-range, that transition is very smooth, and the weighty bass kind of carries on into the mid-range, so that has a nice warm kind of sound to it. And that warm sound works very well for a lot of kind of old school sound, so traditional 80s, 90s R&B and jazz, and a lot of good male vocals as well. Seal, for example, Kiss from a Rose, sound awesome on these inner monitors. And so with that lower mid-range warmth, you get a nice kind of rich sound overall that permeates throughout the rest of the sound spectrum. And so moving on to the upper mid-range, again, that kind of richness is very present. And so having the lower harmonics a little bit emphasized even creates the emphasized notes of female vocals, so the fundamental harmonics of female vocals and violin notes and upper guitar notes and upper piano notes all sound very rich still. And it's a little bit taken back from the center stage a little bit, so I find that the UERR is a little bit colored in that regards, and that the upper mid-range is taken back just a step from where I think would be the neutral point. And that creates a little bit of coloration, but that works very well for a lot of older records and songs that are hotly mastered, and so they would typically have a bright sound. They no longer have that kind of bright sound on the Reference Remastered. Sounds very sweet and not sibilant at all. So talking about sibilance, moving on to the upper mid-range, kind of lower treble area. That transition is also very smooth. It's a little bit of a sizzly sound at around 9 to 10 kilohertz. So it's not too bad compared to other in-ear monitors that I've heard especially. So it's a very nice smooth transition overall. And I think that it keeps a lot of the details without sounding harsh. On the other hand, it does not affect the treble extension very much either. So it has very good treble extension, and it's not the most treble heavy in-ear monitor that I've heard, but it has good extension and it's very smooth overall while keeping all the details still there. So very good on that. And then talking about the Soundstage and the imaging. So the Soundstage of custom in-ear monitors and in-ear monitors, or in-ear earphones in general, hasn't been one of the strong points of that category, and so the Reference Remastered is kind of average in that regard. Of course, you're not going to get the Soundstage ability of speaker systems, because the speaker system's Soundstage is dependent on the room size, and obviously there's no physical room inside of an in-ear monitor because this goes directly into your ear canal. And so the Soundstage overall of the UERR is about average. It's a more three-dimensional blob Soundstage, so nice left and right distinguishing from the front and back and the top to bottom. So nothing too special. And the imaging is likewise a little bit above average from my experience, so it's able to isolate images and instruments within the Soundstage very well from one another. It also depends on the type of music you listen to, of course. But yeah, just solid imaging, pretty good Soundstage overall. So now that we have talked about the sound aspect and a little bit of the Olive Welty Harman target, we can now transition to the measurement section, which I think is going to be pretty interesting. So measurements, we have a lot of them. I had gotten measurements done from Audio Precision as well as from Brüel and Kjær, both at the CanJam SoCal 2017 event back in around April, May-ish. And so I had taken the opportunity to get these measurements done on these Ultimate Ears Reference Remastered custom in-ear monitors, which is not something you see very often. I was talking to Jude from Head5 TV and head5.org, and he had mentioned that he had new ears placed on his Audio Precision HATS system that were more articulate than a more typical HATS system. So his rig is a lot more up to date in terms of the technology being used for measuring stuff. However, when I had asked him about making a custom in-ear monitor specifically for that KEMAR system, that HATS system, the mannequin, he had said that it would be an expensive process, and yeah, I agree. And so because custom in-ear monitors are inherently custom for one's ears, these measurements are not going to be perfect. And so the way I had done these measurements is that we had originally tried to get them inside of the KEMAR head ear mannequin, and as you can see on the screen, both at Brüel and Kjær and at Audio Precision, that didn't work out too well. The seal was terrible. It wouldn't get a good bass response at all. And so what we had tried alternatively at Audio Precision was that we have the sound coupler. And so on the screen here you can see the sound coupler. It's basically a metal tube where you put the in-ear monitors on one end, and it has the measuring diaphragm about in the middle, and then it will output that data to their analyzer system into their computer. And so through this method, I had actually put on some large bore comply foam tips on the end of the UERR. So where the bores are in the UERR, I had put the comply foam tip there, and I had scooch down the foam tip so that the tip of the foam would not cover the tip of the in-ear monitor. So that would both allow me to get a more accurate sound profile measurement done, as well as be able to get a good seal in this coupler. So because the in-ear monitor was being held basically by foam, I had to physically hold the in-ear monitor pieces in the sound tube by hand. And so it's, again, not a perfect system, but it's the best that we were able to do at the time. And so with that being said, I will talk about the different measurements that we had done, both on the audio precision rig as well as the Brüel and Kjær. So I'll start with audio precision because they had a more comprehensive suite of measurements that were able to be done. And I will show you on the screen right here the RMS levels and distortion. Again, this is referring to the diffuse field and the free field compensation curves that I had mentioned earlier. So in the diffuse field here, you can see that it looks not exactly flat. So if you had so what these measurement compensation curves are is that if you had an earphone or headphone that measured exactly the same as this diffuse field or free field, depending on which compensation curve you choose, it would be a perfectly flat line. As you can see on the screen here, it's not quite a perfectly flat line. It's actually a little bit warm tilted in terms of the audiophile speak. Warm tilted is a clockwise tilt from the frequency response. And so as you can see on the screen, there's a kind of a warm tilt on that. So on the bass is a little bit elevated from the 0, which would be the 1 kilohertz region. So at 1 kilohertz, that's where they measured the sound pressure level from. Their audio precision amplifier would output a certain voltage to the custom in-ear monitors, and then it would measure the sound pressure level inside of that coupler. And so as you can see, from the 0 point of 1 kilohertz, the bass is a little bit elevated, the treble is a little bit shelved. As I had talked about earlier, this would be kind of alluding to the typical Harman target response. And so as you can see, between 2 kilohertz and 5 kilohertz, there's actually a dip in the response there. That might be the reason why here the upper mid-range has sound a little bit laid back from what I'm typically used to. And then from 5 kilohertz to 8 kilohertz, you can see that there's a kind of a bump there, and you can kind of imagine that's where I get the sizzly sound from. It's a little bit of a sizzle sound that can give the UERR a little bit more detail in the treble, and then the treble just kind of rolls off from there. Again, these are not completely accurate responses, so the lowest of the bass response and the highest of the treble response may not be totally accurate from what they actually are. And again, you can't really compare these measurements to other measurements you see because this is on a very specific measuring system that may not be the same as others, and these are my custom in-ear monitors with my method of getting these measured. So on the screen, you'll see here the free field response, and then I will kind of switch between the diffuse field and the free field, and you can get kind of an idea of how the two compensation curves work. As you can see on the diffuse field, the bass is a little bit lower in terms of the level compared to the free field one. That's because the free field compensation curve has a lower bass response. So I will kind of compare the free field graph that you see here to the diffuse field one. And as you can tell in the especially the upper mid-range area, you can see that the two compensation curves are a little bit different. Again, as I mentioned earlier, the diffuse field tends to have a little bit of a lower response there compared to the free field. So if you look at the free field, the graph is going to have a higher measurement in that area. And then on the bottom there, you can see the distortion, the THD that was being measured. And so this is expressed in decibels. And so the audio precision folks had mentioned that anything below, I think it was either 60 or 70 is pretty good overall. And I will get into this a little bit more a little bit later. And so Now if you take a look at the screen, you'll see the RMS levels and distortion of the UERR at the top. That is the native UERR plugged into the audio precision system. And then the UERR with the UE buffer jack, and the buffer jack is again what I had mentioned earlier, kind of similar to the iFi iEMatch. And then on the bottom you can see the iEMatch response. And so as you can tell from these three frequency response curves, they're all very similar. So that's good in terms of these attenuator devices such as the UE buffer jack. And so it doesn't really affect the sound in terms of the frequency response there. And as I mentioned in my previous video, the iFi iEMatch on the ultra setting is a 24 decibel reduction. And as you can see on the screen, it's about a 24 decibel reduction in the sound pressure level. So pretty accurate device in terms of that. And the bottom, you can see the distortion. This part isn't too significant because the top distortion graph is the native UERR, and then the ones below that are the iFi iEMatch and the UE buffer jack. And because you get a lower signal, a lower input signal, you will have a lower output of THD ratio. So that kind of makes sense for the iEMatch and the UE buffer jack. So speaking of the THD ratio, on the screen here you can see the THD ratio expressed as a percentage now. So this is typically what you would see in a THD measurement. And yeah, it's pretty good overall. Again, this is not a perfect system. Things are generally below 0.5% distortion, so that's good. Moving on, again, talking a little bit more about the compensation curves and how this measurement system works. These are the relative levels of the frequencies that were measured on the audio precision measurement system, again with 1 kilohertz being the 0 mark. So you can see the bass is elevated about +4, which is exactly the same as the Harman target response. And the treble and the upper mid-range is kind of shelved to all the way up to -20 decibels, as you can see there. Again, you can see the kind of big spike between the 5 to 8 kilohertz range, which might indicate the sizzly sound that I hear, as well as the dip between 1 kilohertz and 5 kilohertz as the upper mid-range is taking a step back. And so I will show you the relative level of the free field. Again, pretty similar overall to the diffuse field, but it has a higher treble presence because that's the way the compensation curve is. And so you can see that those are pretty similar. Moving on to left and right tracking. This measurement's pretty straightforward. It just takes into account the response from the left side and the right side and then sees if it's any different. So as you can tell, it's awesome. Very little tracking. The errors between the left and the right, it's all within the audio precision specifications, and it's pretty much 0. So the left and right tracking is very good on these earpieces. And so moving on to phase, again, the lowest frequencies and the highest frequencies are probably not going to be too accurate based on how this measuring system was put together. But as you can see, the phase is pretty much in line at 0 degrees from 40 hertz all the way up to 6 kilohertz. So not bad. And then it just gets crazy after that. Next up, we have the impulse response. So they would input an impulse response into the system and measure how quickly the signal decays from the output of the drivers. And so this is used to test how quickly the drivers can respond. As you can see on the screen, this is not the cleanest impulse response, but it does show a quick response lasting only about 1.5 milliseconds. So it's a pretty fast system overall that might be able to help with the imaging ability of a headphone system. So with that, we will move on to the Brüel and Kjær measurement system. I had tried this both on the HATS system, so the mannequin again, as well as their sound coupler tube like the audio precision folks. And unfortunately, the only data that they saved was from the HATS system. So as you can very clearly see on the screen, it measured terribly in terms of the bass because there was no seal. And that is crucial for getting a good sound for these custom inner monitors, is that you want a good seal so that you can have a good bass response. And so, as you can see, there's a huge roll-off of bass from like 800 hertz below on this measurement. And then you can also see that there's a huge amount of THD increase from that same frequency range. However, Brüel and Kjær had sent me this data in an Excel spreadsheet, and I had taken that data and put it into the MATLAB software, manipulated the output a little bit so that it measures linearly instead of logarithmically. And so on this graph, you can see that everything is mapped in a linear fashion, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in equal increments and spacing on the x-axis here, so that it matches the treble, or it maps the treble very well, comparatively speaking, and it pretty much masks the terrible response from the bass. And so, as you can see from the treble here, it looks pretty similar overall to the audio precision. If you map this on a log scale like in the previous graph, you would see that there is a bump at around 6 to 8 kilohertz. But in terms of the linear frequency response here, it's harder to see that difference. So you can see a general downward sloped graph, again, kind of matching the warm tilt response of the frequency response. And then if we look at the distortion, again, on a linear scale, it's pretty good overall. The THD percentage is expressed in base 10, so 10 to the 0 power is equal to 1%. 10 to the negative 1 is equal to 0.1%. So pretty good distortion overall. Alright, so that sums up the measurement system of audio precision and Brüel and Kjær. And now my concluding thoughts. And so again, I want to thank Kelly Bishop at Ultimate Ears for giving me a very good promo on these in-ear monitors. It was a really fun experience that I had wanted to experience back in 2004. And so I just wanted to thank Ultimate Ears in general for making this even possible. It was quite the journey to be able to take what I had wanted to learn as a kid and then now experience that as an adult. Kind of a fun process. And so thank you for watching. If you want to learn more about the True Tone drivers or the sound engine technology of the UERR, I can leave the patent links below. Kind of an interesting read. And if you want to learn more details about any custom in-ear monitors in general, how they sound, or any questions or comments about audio that you have, feel free to leave a comment below. Otherwise, thank you so much for watching. Thank you for your attention. This was a very long video, but thanks for bearing with me on this. This has been something that I had wanted to do for a very long time. So thanks for watching, and I will see you again soon.